Hello class, Namaste, good afternoon, and welcome
Good
everyone.
afternoon, sir.
So, are you fine there?
Good afternoon, sir.
Good afternoon, Namaste. Okay, so I think we should start our class. Let's begin. Are you ready for the class 9? Ready?
Yes, sir.
So please, yeah,
Sir,
you have copy, book, and pen with you, I think. So how many of you, okay, try to attempt that question, numerical question that I had given last time? Niranjan
sir,
sir.
finding distance one.
Yes, Chandra, finding displacement distance.
Sir, that a car starts to move from rest one.
Yeah. Same
Yes, sir.
question. You did that? Okay, good.
Yes,
Thank you
sir.
so much.
I get 36 meters as answer.
36 meter only.
Yes,
Okay,
sir.
we'll see the solution. Okay, don't worry. Niranjan sir, Ranjila miss, are you there? Ranjila miss, Niranjan sir कोही हुनुहुन्छ? Ranjila miss.
रोशन सर स्क्रिन सेयर इनेबल भइसक्यो है
Okay, thank you, miss. Yeah, म त्यही नै खोज्दै थिएँ, miss. हस्, thank you. Okay, let's start today's class. Okay, for this, let me share the screen, slide. Yes, class 9. I think this is the question. So, which I ask you to solve. The question is, a car starts to move from rest. The condition is there. Okay, a car starts to move from rest and attains an acceleration of 6 meter per second square. 6 meter per second square is the given acceleration after 12 seconds. And the question is asking you to find the distance covered displacement. Okay. And for solving this question, class 9, first we have okay listed the given quantities. In the given, you can see initial velocity u, small u for initial velocity, which is 0. And why we write 0, okay, for the initial velocity? Because the condition is there in the question, the car starts to move from rest. And let me tell you, class 9, when any object starts to move from rest, for that object, the initial velocity is 0. And when a body comes to rest, means when a body stops, okay, stops, stops, and for that body the final velocity is 0. And this is the questions where we have initial velocity equals 0, acceleration a equals 6 meter per second square, time taken small t equal 12 seconds, and you are asked to find displacement small s equal what. Okay, so reading the question carefully and finding the given quantities and the quantity to be found. Okay, here we found there is the relation among initial velocity, acceleration, time taken, and displacement. And which equation of motion is there? Okay, which has all these quantities related, and that is s equal ut plus half v square.
Second,
Yes. Yes, thank you. S equal ut plus half at square, where we have substituted the value u is 0, okay, and into the time is 12 seconds. So in place of t we have put 12 and plus, okay, from the equation as it is 1 by 2 also as it is as constant there, into, so how much acceleration a, that is 6. So we have put the value of a, okay, which is 6 over there, and into t square. So t square means it should be 12 square, right? And by calculating class 9, 0 into 12 is obviously 0, and 0 plus something is something, and something is there. So we have 1 by 2 into 6 into 12 square means 144. Okay, and 1 by 2 into 6 means 3, and 3 into 144. And finally, we got distance covered is equal to 432 meter. Right? So the distance covered by the car is 432 meter. The question has given you initial velocity, okay, in the language form, oscillations, okay, with the value and time, okay, even with the value, and asked to find distance. So this question shows the relation among u, s, t, and a. So we have used this equation of motion as equal ut plus half a square. Okay, in the coming days we'll practice numerical problem. Don't worry. But today, class 9, so we are going to discuss another topic, and the topic is, okay, inertia. Okay, inertia and mass. So the new topic we are going to connect, okay, in today's class. The topic is inertia. So we'll try to, okay, know the meaning of this term. What is inertia? Okay, what is meant by inertia? Then, so we'll also try to find the relationship between mass and inertia. Okay, does really mass of a body affect the inertia of that body or not? If the mass affects the inertia of that body, then how does it affect? What is the relationship between mass and inertia? Okay, first of all, let's know about inertia. So inertia can be understood by two ways. Okay, in one way, a negative sentence. Okay, and another way is positive sentence. That means when we have to, okay, say the answer of the term inertia, so by two ways we can give the answer. So in one way, we can use the word inability. The inability itself is a negative word. The meaning of inability is unable to do, cannot, okay, does not do. And another way is in positive way, just opposite way, using the word ability. And let me say to you, dear students, please listen carefully. When we are reading the term inertia, we have to get the concept of, okay, position of a body, that is a rest or motion of a body. And you know very well, according to Newton's first law of motion, body remains in its own positions, either at rest or motion, unless external force is applied on it. Okay, let me take the example of books in the bookshelf. Okay, we can see in many houses the books are, okay, still in the bookshelf for long time. Okay, if you keep any object on your table and does not try to touch it or does not apply force, okay, from your side to move it, so it does not change its position, it remains in its own position. Whatever the position of a body is, so it can remain in its position. That is the positive way we are saying. Okay, that is the ability. That means a body has ability to stay in its initial position. If the body is at rest initially, the body can remain at rest forever. Okay, it can remain at rest unless, okay, force is applied on that. If you do not apply the force on any object, the object, okay, remains in its own position. Means the body cannot change itself, okay, its own position. That means the body cannot change its position either from rest or from motion, okay, by itself. So in one way, in a negative way, we can say that the inability of a body to change its state or position by itself, right? And in another way, we can see in a positive way is the ability of a body to remain in its state. And this inability by which it cannot change its position, or the ability by which it can stay in its position, is the same thing. Okay, that has the same meaning. And that inability by which it cannot change position, or the ability by which the body can stay in its own positions, okay, unless force is applied on it. Okay, that property, that tendency is called inertia. Okay, when a body starts to come in motions, okay, the body continuously, okay, that remain in its motion, in uniform motion in a straight line. Whenever we kick a football, you can see the body football comes into motion. Okay, in fact the body stops because there is the force, okay, between the ball and the ground that stops the ball. That force is frictional force. So due to frictional force, okay, the ball in motion comes to rest, okay, while we are playing football on the ground. If there was no frictional force, okay, or any force which do not, okay, come during the motion of the football, and what we have to say is the body still or continues to be in the state of motion. So the body in motion always can be in motion, and the body at rest can always be at rest. And to change the body from motion to rest, or from rest to motion, now externally we have to apply something which we call external agent on that body. Only then the body changes its position. Okay, the body comes to rest from the motion, or body comes to, yes, motions from the rest. And that external is force. So if we do not apply the force on a body, body remains in its own position. That means body is not able to change its position by itself. It can change its positions only when the force is applied on it. This is very general, okay, that concept. And practically we have experienced many times in our real life. Okay, whenever we apply the force, then only we're able to change the position of body. And when we do not, okay, apply any force on the body still remains in the same state position. And that tendency, that property, okay, is called inertia. Okay, though it is a new word, a new term for you, dear students, please then do not get confused. Simply, inertia is the property by which a body can stay in its own position. Okay, this way also you can say the answer. And another is what? Inertia is the inability of a body, okay, to change its state by itself. Inability to change means ability to stay in its position, right? So this is the property, and this is the tendency, and this property of a body is called inertia. Okay,
Excuse me, sir. The second
and
and
due
third
to this property
derivation.
strength, the body always, okay, remains at rest. If initially it was at rest, and the body always goes in motion if initially it was in motion. But we have force, or we apply the force, and we change the body from rest to motion. Okay, or naturally it happens. Let's see one activity over there. Okay, this activity shows a little relationship between the inertia and mass. I hope the students of grade 9, they have got the concept of inertia, okay, by little. Then that means the body at rest always remains at rest. The body in motion continues in the, and to change them, so we have to apply the force externally, and that force is unbalanced force. Now let me tell you one simple activity, okay, which shows, okay, inertia and the relation between inertia and mass. Okay, you can see in the picture, dear students, there are two buckets, okay, taken. They are of equal size, and they are suspended. Yes, we will hear. Sorry for the interruption, dear students. Okay, let me rejoin and continue this lesson. So we were describing this simple activity that shows the relation between inertia and mass. For this, we have taken two cans, so which are suspended on a bar with a string. And how are they kept? One can is kept empty, okay, And you know this twins, the empty can has less mass, right? And another can is filled with sand. So there are two cans. So one can is filled with sand, okay, and another can is kept empty. And before, okay, applying force on them, you know, okay, to bring them into motions, obviously, so you will feel difficult to move the can filled with the sand. Yes or no? Okay, if you try to move these two cans, okay, in turn, and to move empty can, definitely, okay, you feel easier. And to move or to bring this can filled with the sand, okay, which has more mass, okay, into motions, obviously in compared to empty can, you will feel, okay, more difficult. That means you feel that you have to apply more force to bring the filled, okay, can with sand into motion. So before, okay, applying the force, when these two cans, okay, are at rest, and you are about to move them, you are about to bring them into motion by applying the force, because we have already discussed, okay, unless we apply force on them, they themselves, okay, won't come into motion, because at first they are at rest, and it has inertia to be at rest. Now, after applying the force, okay, both the cans now are in motion, and you can see the movement of both cans. Okay, and during that time, okay, while applying the force, and you already observed that, to move a can filled with sand, okay, you feel little difficult, more difficult than to move an empty can, isn't it? This means what? The can filled with sand has more inertia. That means it can remain in, okay, in the state of rest. So to move the can bucket filled with sand, which has more mass, okay, you need to apply more force. Anyway, you have brought both of them into motion. Now both the buckets, okay, are moving. Now when you observe, so what do you find? So okay, between these two buckets, okay, between these two cans, so which one oscillates? Okay, oscillates means moves to and fro. Okay, that front and back, left and right. So between these two buckets, which one oscillates for a longer time after they both come into motions? So when you apply the force on them, okay, obviously, dear students, okay, it will emerge to you the can, the bucket filled with sand oscillates more time. Okay, it will oscillate a longer time. That means, so when you stop applying the force on it, okay, as they are in motion, and after some time they come to rest, okay, because there is also some force which bring them into rest. And when they come into rest, empty bucket, okay, comes to rest at first, then only the bucket filled with sand comes to rest. So at first, when you were about to move them by applying the force, that time also the bucket filled with sand, okay, could not easily come into motion. To move the bucket filled with sand, you need to apply more force, right? And when they are brought in motion, and after some time, when they come into rest, okay, this time also the bucket filled with sand, okay, comes to rest later after some time. That means the bucket with sand, okay, at first, okay, is not able to come into motion easily. Now when it is brought into motion, and later on, now it is also not able to come to rest. Okay, and this activity shows that the property called inertia of a body is directly proportional to the mass. Okay, remember this. Okay, listen carefully. What is the relationship between inertia and mass. And in short, we can say directly proportional. More the mass and more the inertia of a body. Okay, in between these two buckets, the bucket filled with sand has more mass. So at first also, it could not come easily into motion, right? It tried to be at rest. And when it came in motion, later on, now it could not easily come into rest. It, okay, tried to remain in motion because of its more mass. So in between these two buckets, empty and sand-filled bucket, sand-filled bucket has more mass, okay, comparatively, due to which it also has more inertia. So more mass, okay, and more inertia. Now if you are riding bicycle, obviously you can easily stop the bicycle by applying the force with your brake, right? And if you are driving a heavy truck, feel at the time, okay, to stop the heavy truck, loaded truck, obviously you have to apply more force because the heavy truck has more mass than the bicycle. If you are moving both the vehicles, bicycle and truck, manually by your physical force, okay, you can easily move the bicycle by pedaling, okay, by moving the pedal by your legs, you can easily, okay, ride the bicycle. But to move, okay, truck, no, physically, okay, your force is not enough. For that you need the force and power from engine. Then only you can, okay, ride the truck or you can drive the truck. Why? Because so to move bicycle is easier than to move the truck, right? So and to stop the bicycle is easier than to stop the truck because the truck has more inertia. It cannot easily come into motions when it was at rest, and it cannot come easily into rest when it was in motion. It has more inertia than the bicycle. Both bicycle and truck both have inertia, but comparatively, okay, truck has more inertia. Why? What is the reason behind this? The reason is mass. Okay, truck has more mass, due to which, okay, that truck also possesses more inertia. Understood? So the relationship between mass and inertia is inertia depends on the mass and inertia is directly proportional to the mass, less inertia, and more mass, more inertia. So why students, if you pick a small stone and you can easily throw the small stone to a greater distance, but if you try to lift or pick big stones, I think you may not, okay, because that big stone has more mass and it has more inertia. Okay, it tries itself to be in the state of rest. It cannot easily come into motion. Now, sorry, okay, thank you so much. Okay, let's see here. Once again, let's know, recap what is inertia. Okay, inertia is the tendency or the property by which it is not able to change its position itself. Okay, that means it always resists changes. To change their position, we have to apply the force. Then only it comes into motions or rest or it changes position. Okay. Yes. Let connect another topic, that is types of inertia, class 9. There are three types of inertia. One is inertia of rest. Second one is inertia of motion. And the third one is inertia of direction. And we will be discussing only two types of inertia. Inertia of rest. And simply, okay, inertia of rest is specifies the position. So when a body is at rest, initially, if the body does not change positions from rest, okay, that means it does not come into motion by itself, and that property is simply called inertia of rest. So inertia of rest is the ability of a body to stay at rest. Means it is the inability of a body at rest to change its state from rest. Okay, if the body is already at rest, that means itself it cannot come into motion. It cannot come into motion means that is the inability of a body. Okay, the inability of a body to change its position from rest by itself is called inertia rest. Okay, and according to the law of inertia of rest means a body continues to be in the state of rest. So if you have to change a body from rest to motion, what do you need to apply on that body? Obviously external agent, okay, called force, and that force should be unbalanced force. Unbalanced force only is able to change the body's positions. You can bring the body from rest to motions or motion to rest. Now here, let's see some examples of inertia of restraints. So in the picture you can see there, okay, the fruits are falling from the tree. Now let me tell you something about this. Okay, you can see the fruits are in the tree or the plant. Okay, directly you can pluck the fruit from the branch of the tree, or sometime what we do, okay, we shake the tree or we shake the branch. So when we shake, okay, the branch of a tree, okay, that branch has a number of fruits on it, and when we move the tree, okay, the tree which has number of fruits on it, then you can see the fruits fall down. Okay, and so when the branch of a tree is shaken, the fruits get detached from the branch. Okay, the fruits get disconnected from the branch and they fall down. This is because of inertia of rest. Okay, before we shake the branch, before we move the branch, both the branch and fruits, okay, were in the state of rest. Okay, both fruits and branch, both fruits and tree, they were in the state of rest. Now, when we shake the branch, when we shake the tree, that means we are applying the force on the branch. Okay, we are applying the force on the tree, and by the force which we applied, the branch come into motion. Okay, the branches come into motion because at the time the force makes the, okay, change in the position of the branch of a tree or the tree. So if you apply the force on the tree comes into motion. If you apply the force on the branch comes into motion. But the fruits, they are still at rest. Okay. So where we apply the force, okay, that part acquires the change in position, change in state. That part comes into motion. But the fruits, okay, on the branch, they are still at rest because of inertia of rest. Because so we have not applied the force directly on the fruits. So why the fruits remain, okay, in the same position, that is rest. And this is one example of inertia of rest. So whenever we try to shake the tree, so you can see that water droplets fall down. Okay, flowers or leaves of the plants fall down. Because when we apply the force on the tree comes into motion, but the, the leaves or the flowers, they are still at rest. Then when one part is in motion and another part is at rest, now they get detached, they get separated. And finally, same way, similarly, the fruits also get detached and the fruits fall down. Okay, as we shake the branch of a tree, the fruits fall down because of inertia rest. When we shake the branch comes into motions by the force which we applied, but the fruits are still at rest, and due to inertia of rest, they get separated and fall down. Let me show another example also. Okay, if you see this picture, dear students, you can see, okay, the conditions of passenger inside the bus. Okay, if you see the postures of passengers inside the bus, okay, you can find little, okay, little they are leaning backwards. So what is the condition here? Okay, the bus was at the state of rest. So when the red light is, okay, given, the bus stopped. Now the bus, okay, along with the driver, passengers, they all are at rest. At the green signal, green light is, okay, emitted or given. Now suddenly a driver, okay, applies the force on accelerator. That means a driver starts to move the bus. And now when a driver applies the force on accelerator, okay, to move the bus ahead, the bus comes into motions, but at the time the passenger inside the bus, okay, do not come into motion. Okay, the driver applies the force, okay, on the bus, so the bus comes into motions. At the same moment, okay, the passengers do not come into motion. So why the passengers now lean backward. So when a bus suddenly starts to move forward, okay, from a rest, passenger inside the bus tend to stay at rest due to inertia of rest. So why strange? When a bus is moved, okay, suddenly and obviously that the passengers lean backward. This is because of inertia of rest. Understood? Now next example also I have. So you can see this example, this strange. This is the example of inertia of rest. So there is the glass filled with water and that is covered with a cardboard. Okay, and on the cardboard you can see a coin. So over the glass you can see two, okay, objects. One is cardboard, so on which, okay, we have kept the coin. And right now students, the coin and cardboard both are at the state of rest. Now when you, okay, suddenly pull, okay, when you suddenly pull the cardboard from it, and you can find one miracle happen there. The coin drops or the coin falls, okay, into the glass. The coin does not come, okay, along with the cardboard. Okay, this is also because of inertia of rest. So when you immediately pull the cardboard comes into motion because the force you applied, but the coin is at rest. And the coin remains at rest, okay, and the cardboard comes into motion. And the coin remains at rest means it is because of inertia of rest, because we have not applied, okay, force directly on the coin. So when we do this activity immediately, you can see that coin, okay, gets separated from the cardboard and falls inside the glass. This is because of the property, okay, of a body at rest, and that property is called inertia of rest. The body, okay, at rest always tends to be at rest. It only comes into motions when we apply the force on that body. If the force is not applied, okay, then the body does not come into motion itself. Understood? Okay. More example here we have the inertia of rest. So you can see the holes on the, window pane. So this is the holes made by bullets of the gun. Okay, the glass is not broken, the other parts of the glass is not cracked, only you can see the hole made by the bullet of the glass. Okay, is it possible? Obviously. Okay, this is also because of the inertia of rest. So the part, okay, where the bullet strikes, that part comes into motions, but the other parts, so they are still at rest. And due to inertia of rest, the bullet that travels so, fast at a higher velocity can easily make the hole on the glass without cracking it. Understood? Okay. Now next is we have inertia of motions. Okay, it is just opposite to the inertia of rest. The inability, okay, of a body at rest to change itself, okay, from rest is called inertia of rest. Now inertia of motion is the inability of a body, okay, to change, okay, its positions from motion. If the body is in motion, the body continuously, okay, remains in motion. This tendency or property is called inertia of motion. Okay, if you have to bring the body from motion to rest, then only we can change when we apply the force. See, example of inertia of motion. Okay, in this case, you find that the posture of passenger inside the bus. Okay, initially the bus was in motion. Now when the drivers, okay, sees the red light that is shown or given, and he suddenly applies the brakes. At the driver suddenly